Hi, I'm Praveena. So just the logistics, make sure you rate the session, and please do, if you have any questions, please do put in there as well. I'm really interested to hear what you have to say, or what have you observed and things like that. I know that Sam has already given me an introduction, but I thought I'll just do it again. I'm a software engineer at Neo Technology, or like how my Swedish colleagues would say, Neo Foyer. So I want to talk about microservices, but before I proceed to present my case study, I just wanted to understand, to get a bearing on the audience, so that I don't use a ton of jargons and I don't explain things that this audience already knows. So it'll be easier to skip through the parts, the obvious ones at least. So how many of you have worked with microservices? Okay, that's good. How many of you are developers? Okay. How many of you have worked in an agile methodologies? How many of you have used good? So that's yeah. So that makes things really simple. So microservices is a software architecture style where you compose complex applications into small independent processes. When you look at microservices, almost all major conferences around the world have a separate track dedicated for microservices. And it's not just in terms of software architecture style. Even specific language conferences have specific tracks on microservices. So it's been gaining a ton of momentum in the recent years. And the places which use microservices are companies like Pinterest, Twitter, Halo, Uber, and ton of these things which I already use, and I'm sure many of you are end customers of these services. Netflix at least, come on, who isn't a customer of Netflix? So when you look at these companies, you see that all of them have been there for maybe maximum a decade, you could say. And they have a lot of young engineers working there. And in terms of legacy, they don't have much to carry it around in some sense. Whereas and the things that microservices brings in are the kind of small gifts that comes along with using microservices. The ability to do quick deployments. You can release something to production and then look at the feedback and try and adapt to the feedback as quickly as possible. And you can scale up and you can scale down services as however you like, based on how your user consumption is. And it's very, very easy to enhance features or to add features. And the path from when you start development to when it is deployed is reduced so rapidly. So these are the kind of small gifts that comes along with microservices. But what about age-old systems? I worked in a place as a consultant where we had to we were in an environment which had Microsoft servers behind this huge what do you call it, architecture, and we don't know what was happening there. But what we knew was that the customers were kind of seeing patterns where they saw new startups which came into their own space, their own publication domain, where they were able to quickly add features, the ones that they have been trying to add for years, and then eating into their user market. So they were in a position where they were still market pioneers, but they slowly saw their user base being corroded away by tons of new startups in their space. So they really wanted to change how they work, and they wanted to change how they deliver software, because ultimately that's what that's the interface to their end users. This web page that they were that is what they were serving to the end users. So I was not just me, my team were dealing with a 20-year-old system which was written in C. And the team did not have any business analysts at the beginning. And we were basically given a part of the code base, not the entire one, a part of the code base where we were told like, okay, this is the thing. You don't have any business analysts. You have to go ahead and like re-engineer code. We don't know how things work or why things work, but we want it to be exactly the same because we don't want to lose any user base because some features are not there which they were like used to before. And the ultimate goal that they wanted to have was also like they were moving like a development, their development center from across continents. So they wanted to like say, okay, we've got a new development center in and we are like going to transform how this thing works. And we want to prove the success. Like, remember the good old days when you were taking like 3 months to like just release, not develop, just release. We are done with that. Now what we want you to have is basically like write code and then like release it maximum in a week. Like that's the target that they were looking at. And with any business critical application, you always have tight deadlines, which was the case in our system as well. So when we looked at, when we saw how people are tackling problems like these, we saw microservices as like the future, this like great world where like it answered like every single problem that we were having. We wanted to release quickly. We wanted to gauge customer feedback, and yeah, basically. So when we looked at microservices, we felt that it is like, it's the future, like yes, that's the answer, that's where we want to go to. But it also seemed like an utopian mystery to me because when you look at, so just to get some basic definitions, utopia is like an imagined place where like everyone exactly knows what they're supposed to do and everyone have a purpose in that world. And a mystery is something that like, it just explains what it is. Like, it's impossible to understand or like explain it. So like when I was looking, when I was given this project and I was looking at microservices, that's exactly how I felt. I felt like it is, all of this is like great, but it's used by companies which are there for like 10 years and they basically know what they're doing and they know their software well, whereas like we were in that place. So it looked a lot like utopian mystery to us, but we still decided to like steer on because we were like, okay, we need to start delivering and let's just do something and see how it works out. So we decided to use microservices for our application. So we initially thought that our monolithic application is going to be like that, like this beautiful multi-tier. Oh, this is great audience, thank you. Anyways, multi-tier cake, and we were all like balancing it greatly. And it's going to be like when we change it into microservices, it's going to look like that, where you have like the same tiered architecture, but you have like smaller cupcakes where it's like divided into like really small, tiny nuggets, and you can just like go ahead and like bite onto it. But reality was much like this, like literally, like not literally, figuratively, it is like this. I don't want to be like, yeah, so it was like this. And it isn't an easy thing when you're dealing with like a big pile of shit, and now you have to like deal with like 10 piles of little poo. Like, it's not like, oh, my earring, sorry. Anyways, like it's not like an easy, it's not an easy problem to solve. So these are basically like, oh, I ran a bit there. These are basically like 10 lessons. And like, if I can talk in length about each one of these and how important this is. But I'm just giving you like a big gloss over what I learned by using microservices. So the first lesson that we learned from doing things wrong was we have to keep it small. And what do you mean by small? What does micro in microservices mean? Is it like the number of services that you have in production, which I'm going to say the answer is no, it's not that. And why is it important to have like small services? It is important to have small services so that you can basically rewrite the entire service if you want. And how you can measure the size of your service by answering this question, which is like, how long does it take to rewrite your entire service? The ideal answer, answer for that should be in the order of 2 weeks. Now, you can say, hang on a minute, Praveena, like I thought you were saying that you're talking about like 20-year-old system. And whatever you're saying right now, it just looks like hipster talk to me. So like why? Why would you ever have to like rewrite an entire service? Like, I think you're like lying or something like that. But there is actually a reason why you want the service to be able to like, to have the ability to be written, rewritten, basically. It is because so that you could work on a story, and you should be able to like deploy it quick to production. So how long does your story take from development to deployment? Ideally, what you would want is like when you pull a story in, when you pull a story in, you want it to be like, like a smooth ride across like this lane. So this was our card wall. And when you pull a story from like analysis into ready for dev, what you want is you want a smooth ride across all this lane, and you have to come to the ready for prod. So that's your ideal situation. And you should be able to like glide on that, like you're riding like a cycle, which is like on a really smooth plane. But if you're working with like a service which is massive, then it's going to be an experience as though like you're riding with this bicycle, because it's not going to be a pleasant experience when you like take a story, do the development, and then push it into test, and then wait because like some other story is like having a dependency on the one that you're working on. So you will run into problems where like you face questions like, okay, I worked on a story to improve like the query performance, and there is a UI bug, and why is like these are completely like unrelated things. Why is my story blocked because of like a UI bug? I don't see any point in blocking my story. But like if you have a service which is like small enough, and it has like one responsibility, and it knows and it does just one thing, then it's very, very simple for you to be able to like make changes to that service and be able to deploy it quickly. And remember, like one of the important things that we had in our application was that it took months to see any changes deployed to production. And this is what we this is why we wanted to avoid, is first to have like a quick deployment to production. So this was very important for us to like keep our services small. The next one that the important thing to realize here is that like you have smaller code bases that leads to like really small context to change, which means that it helps you to like do autonomous delivery. Small isn't just beautiful. It's really practical for you to like deploy small services in a very big environment. So like you have to remember why this is very, very important. Lesson 2 is to focus on autonomy from design to deployment. Now, autonomy is basically the right of self-governance. How does autonomy look like in a microservices environment? You would want, ideally, when you're doing a deployment, you basically say that like, okay, I have developed, and like I was pairing or not pairing, it's fine. Like I'm done with development, and the testing is over on that story. Now I want to go and deploy. And what you want to do is just like push a button and it's deployed, or like it gets deployed automatically. So you basically have like absolutely like no choreographed deploy. You don't have to do any choreography at all. You don't have to talk to people. You don't have to talk to other services. That's what you want. And here is where something tricky comes in. Like earlier I was talking about how your service should be small. If your service is small enough, it definitely would have like dependencies that it needs to like make its work happen. Then in that case, like how can you just like deploy your service without choreography on like its dependent services? Because more often than not, when you're working on a solid piece of work, you do have to like touch multiple services. So like you can again like say that this is like one of those things where like people say one thing, but the reality is actually something else, which was in our case. one thing that we finally succumbed to was basically like saying that, okay, fine, there's always going to be dependencies, and we just have to deal with it. So that was like an important turning point for us, because we tried really hard to like have, oh, no, 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 like you're not supposed to do choreography at all. Like we shouldn't have to do this. We are doing microservices wrong. So like the first step to recovery is like acceptance. So we accepted that there's always going to be dependencies. And now let's have a conversation on how to deal with those dependencies. So what we wanted was no choreography in our deployments. But what we needed was actually easy choreography in deployments, which is why this is like a user story card. And I don't know whether it's really clear, but what you see in this, what you see in this is like 3 different services on a sticky note there and some numbers next to it. So in my project, we used RPMs. So all our services gets packaged as RPMs, and then they are like baked into an AMI and installed. So what we knew was that like when we developed this story, we knew that this one has this. To implement this story, we had to touch 3 different services, and those 3 different services, once the changes were made, were built into that number RPM. So we basically marked those RPM versions on that story and said like, okay, fine. If these RPMs are deployed in any environment, then it means that the story's feature is already there in that environment. So that was one easy way for us to like track how the services are dependent. Is like when you start working on the story, we decide like, okay, these are the services that it's going to touch, and these are and once the development is done, we mark the service RPMs that it was using, and then say like, okay, fine, if you deploy these 3 services, the story is done. It's basically there in that environment. So we made a conscious decision to think about what a deployment strategy is going to be at the beginning of the story development. Like, so when you do an analysis, the first thing that we did was like, okay, this story is going to touch 3 services. So let's just like identify those services and put it on the card. And then when the development is done, you just add the service RPMs there. And when you do have easy choreographed deployments, there's always going to be like breaking changes. The important thing is to like plan for breaking changes. So sometimes when we were thinking about a deployment strategy, we realized that there are going to be breaking changes. So the next thing to think about is like, how do we ensure that like the end user isn't going to be affected when this breaking changes are going to be like deployed? So how do you avoid breaking changes? So we had a bunch of, like a set of tools that we were using sometimes like in conjunction with other things, and sometimes like by itself. So we use semantic versioning. We ensured that we had like a tolerant reader in our APIs. And sometimes we would do lockstep deployments. And the one thing that we used extensively was feature toggles, and feature toggles based on which environment a certain story is in. So while a story is in development, it will be feature toggled on dev environment. But the QA, the staging, the production environment, it would be toggled off. So even when the RPMs actually reached to those environments, until we are able to like test and all of these, all those necessary checks are done, they're actually not available to the end user. So when you have feature toggles and when you ensure that you have like semantic versioning, tolerant reader, and other things, like you can try and avoid breaking changes, or you can at least like plan for contingency measures. So when we did have breaking changes, like if you see this one says here, blocked on some story here, which is like in analysis. So this is one way where we identified like, okay, these stories, although they are independent, if we club both of them together while in development, it's going to take weeks for it to complete and weeks for it to finish testing. So what we would go ahead and do is actually divide that story into like sensible parts and then say it's going to be blocked, so do not deploy this until the other story is ready. So like the developers can continue with the development, the testers can continue with that. And when these two things are ready, then you just basically turn the feature on. So that's one of the important things that when we were able to plan for it, like at the start of development, it made a lot of sense to us. So another important thing that microservices brings along is actually having like an heterogeneous architecture. And this is one of the things that people talk repeatedly that you can exploit to your benefit, to say that like you can choose the tools that works for you. But when you work with old systems, you have to be really careful on like what you're doing. As a consultant, I have the responsibility to ensure that I am not choosing tools that my customers are not able to like maintain it at the end of it, like when I'm out of the door. So there comes a certain responsibility when you're deciding what you have to do. So in our case, we chose things that we knew that is going to add like long-term benefits to customers, and like they were done in like really simple languages rather than like ML or like Clojure, dare I say? But yeah, so we use chat ops, like we use things like QBot to like to make sure like our deployment, like you can basically ask QBot, which is like a JavaScript chat op that you can add it to HipChat and like Slack as well, I suppose. And it will tell you like what's the status of your deployment, and you can tell like notify me when this service is deployed. So you can just go ahead and do your stuff. You could go grab a coffee or something like that, and it will tell you basically when your deployment is done. And other things that we used were like Kibana dashboards, which is like again built on like an Elk stack, and you know like it's saved in like in JSON. So people were able to like interface with it, and it's easier to learn as well. And we were able to like quickly fix, we had the ability to like add like really small cards which would like go through all the lanes really quickly if we know that we are getting user feedback on a certain thing. Like, so that was like, okay, this is going to add short, like long-term value, but it's like a really short thing. So can we just like quickly do this? And this was not just for the end user. This was also for like things that the AppSec people needed, or like things that the DevOps people needed. Like, so we were able to like quickly prioritize stories on those ends. And other things that we did was like automating support scripts. So ChatOps was using JavaScript. For support scripts, we realized like, so I was working on a Java application. Now, Java and scripting doesn't really mix. So we decided we will use Python scripts because like our infrastructure was on Ansible. So we thought like Python runs really good with Ansible. So we wrote like really small scripts, like whenever systems would go down, like if a support engineer were to look at it, how would they do it really quickly? So we wrote these really small scripts. And the next thing we did was like automate those support scripts. Like, so without even the intervention of a support engineer, it will, the minute something goes down, it shows like certain status automatically. So these are just examples of things that you can use even in like age-old systems where it is like really hard to incorporate things. Lesson 4 was to pay attention to the bounded context. I really do think no microservices talk gets complete without mentioning bounded context, because it's such an important thing to consider, and it's very, very easy to miss as well. So bounded context, so this is from Martin Fowler's blog, and Eric Evans on his Domain-Driven Design book talks extensively about this. So in simple terms, bounded context is like you have in any application, you have like you have multiple contexts, and these multiple contexts have like models which are named exactly the same. For example, in a support context, you have customer, and you also have a customer in a sales context. But although these models are named the same, and they kind of indicate the same person, the operations that that person has is completely different. And this is actually a reflection of humans in reality. I'm here as a speaker, but I'm also an employer at, what do you call it, like at Neo Technology. So this happens quite a lot. Like, so people sometimes misinterpret this, and they try and like share operations and models between these two contexts, and that's a big no. Please don't do that. We were bitten really hard by that. I'll show you how quickly. So we had two services, authentication service and the web app. And when the web app is trying to authenticate, it uses like the authentication service returns back a JSON response with the auth token username and some user details, let's say age, for instance. But what the web app needed was a response like this. It didn't need the auth token. But if I were to like import this inside authentication service, then it would mean that authentication service would have to return this response, which is what we did, like honestly, which is what we did, which meant like anytime web app had to change, we had to change what authentication service was returning, which was a big mistake on our part. What we should have done instead is made this transformation inside web app instead of authentication service. So authentication service always gives this one response, and its consumers interpret it in different ways based on what they want. Lesson 5 was choose what works for you and document your reasons. Now, I'm a software developer, and the last thing that I want to do is write pages of Confluence document. But it was very important for us to do this one important step, because like developers like to always like improve the system that they're working on, which meant that we were having the same conversations over and over again about like why are we doing this, and like why this shouldn't be this way kind of thing, which is fair. Like I mean, I would do that in any team that I am in. But what it meant was that like people were getting tired of like explaining this again and again and like try and see what was happening. So one of the things that we did was, when we take a decision on something, just understand the context why a certain decision was taken and just put it up somewhere in a mail or like somewhere so that it's communicated to the entire team about what we are doing and why we decided to do this. And reevaluate it any time where one of those context things changes. So you don't end up having the same discussion over and over again, but you do have the discussion where it matters, when your context in which when you decided when you came up with a certain decision has changed, then your decision no longer applies because your context has changed. So we ensured that we imported certain things like that. An example of this was understanding where our constraints and where our principles came from. An example of principle was, we decided that we will do our validations at every service level, which meant the validations were duplicated, but we were fine. We had good reasons why the validations should be duplicated, which I'll probably cover in a short while. But the important thing was around constraints. There are certain things which you can't change in your project constraint. For instance, I did tell you that I was working on a Java application, and we had Python scripts. Now, when we came to user journey tests, we started with Ruby. And at that point, our clients went like, no, like, we can't do like one more language into the pot. Like, I mean, can you please just pick up something else, like either Python or Java to do this? So we did, like, after doing the user journey tests in Ruby, we decided to change the user journey tests using Java, because Cucumber has like a Java API as well. Yeah, anyways, like, so we decided to do that. And that was, it made a lot of sense at that point why we had to do it, because it was from a constraint which we had no control over. And there's no point in discussing this over and over again, whether Ruby is better or Java is better, when your client says, like, just use Java. So about validations, for principles, we decided to, an example of this is the acceptance that it is okay to duplicate validations. And the important thing, like when I first became a developer, in my training that was taught over and over again was dry. Do not repeat yourselves. So why would I want to duplicate validations? Because that's one of the tenets of like software development. You never repeat yourself. But it comes like from a greater understanding where you understand that, like, okay, fine. There are certain duplications which you never want to do. But then there are like certain duplications which you should be doing. For instance, an example of this one would be, say, validations, like where you have like your client-side validations in JavaScript when a user is entering something and you say you match like an email or something like that, and you say like, well, this is not a valid email address. So that's something that you would do in JavaScript. Whereas when you're trying to save something in your database, that's a completely different kind of validation which you should be doing, which is does it have any SQL injection in it? Does it have like Bobby tables? And things like that. So these validations serve two different purposes when it's done in the client side versus when it's done in the server side. And it is a good thing to ensure that like you do validations wherever it is necessary. In some cases where we had to like duplicate validations, or we needed to like check this over and over again, an important there was like this tension between like, okay, do we make shared libraries or shared clients, or do we just like accept everything that comes by? And in our case, we decided to do both. So like in like one of the services which I was taking care of, the service itself published like a client for any of its consumers to connect to the service. So the client had all the validations that the service would do. So like if you were to use the client, then you can just, you can ensure that all the validations are done. But there were times where like you don't want that thing, you don't want to like use shared client, but you want to use instead a shared library. An example of an example where we used like a shared library, which is a very good layer of abstraction, was managing negative TTL caching. So we used ELBs, and like when you have when your ELB switch is being made, like your service endpoint switch is being made, at that point, like there are times where like your negative TTL caching affects the service discovery. So when we had to abstract that, so that was a very important thing for all the services to basically have it done the same way. There was no reason for it to be done in two different ways. So that was a very good example for us to do something in like a shared library. And an example of like abstracting something which we shouldn't have is abstracting models into shared libraries. An example of this is what I spoke about earlier. So we saw that the support context and sales context had basically customer and like product shared. So someone thought like, I mean, I think in all fairness, it could have been me. It was like, oh, like I know what to do here. We're doing the validations again and again. Let's just do the smart thing. Let's just like extract that into a separate library and then like ensure that those domain models are basically shared between those things. What it did was basically like remove this boundary completely, and it made this entire thing into a support and sales context. And it was a mess. Like, I mean, we couldn't add any features to one context without affecting the other, which is why we wanted the microservices in the first place, which is why we wanted to keep it small in the first place. But what's the point of keeping it small when you like share libraries in between? You might as well have both of them together, which was a costly lesson for us, because by the time we wanted to change the web app to do something else, it was very much tied to authentication service, and it meant that we spent like a month or so like trying to strip away features from web app, and it was still a mess, which is a shame, really. Lesson 6 is to embrace Conway's law. So this is one of those things that gets mentioned along with bounded context time and again in any microservices talk, which is Conway's law. Like, I mean, Conway's law is basically something that has been like proven again and again, where when you try and come up with a solution, your solution is going to like mirror what your organization structure is. So instead of fighting Conway's law, it's very, very useful for you to like embrace it and make it work for you. An example of that is deciding between these two teams. So initially we had like an UI team, which is why we had like a web app service. And then we had a platform team, which is why we had like multiple, we had like one AWS like deployment architecture. And then we had feature teams, which meant like we had like features in between. But what this meant was that like anytime you had to add a feature, it is going to touch both the UI team and the feature team and the platform team, which meant you had to like somehow coordinate like giving or like splitting work across these 3 different teams and like deployment between these 3 different teams. So it's a mess. Like, I mean, as I say it, I can realize like, how difficult, it's like a trauma. It's coming back all to me. Like, so it's not really a good feeling for you to like, the last thing as a developer you want is like sit in meetings about how you should develop code or like how you should deploy code. And you're like, this is what I wanted to avoid. Why am I here again? So an important thing that we decided, like after trying out the wrong way of doing it in that context, is try and do it a different way, which is like actually make our teams, like our feature teams, have UI developers, have a platform person, and importantly, have a product owner within that. So when we had like a product owner team, I don't know, like somehow it was making things really difficult when we had to like make decisions. We had to send emails, wait for a long time, and like wait for a long time for it to like get business owner approval and things like that. The minute we actually had a product owner in our team, when he was attending on stand-ups, everyday stand-ups, it was very easy for us to just go like, okay, what do you think about the story? We have tested this. Should we just deploy this? And he goes like, yep, sure, deploy it. And that's, at the end of the stand-up, it was deployed, basically. That's how simple things became in terms of deployment. So what you want to have in your team is a vertical slicing of teams instead of having like horizontal slicing. And other things that we used Conway's law to our benefit was to have self-contained systems and like talking to a product owner about like, look, you're the product owner, you give us the requirements. You're not like stopping from changes happening because we are basically in this together and we need to like work out how we are going to work out. Like it's not like I'm suggesting something and you are like, no, that can't go in. It's instead the other way around where like you're suggesting us something and we are going to make sure that that change is actually in. And that made like tons of difference. Lesson 7 is to take monitoring seriously. I can't stress how important it is to ensure that you monitor your systems because things can go wrong easily. Like, I mean, when you have one thing to take care of, you just have to like sit and stare at that one thing. Whereas when you have like hundreds of things to take care of, you would go mental about this. So like it's important to like take your monitoring seriously and ensure that you have like proper alerts to just alert the important things, not like or like some region, like a region went down is an important thing. But like an instance went down, maybe not that important because you do have like ELBs and things like that in front, which can take care of it. It can be like a post-mortem. So you need to understand at which different levels you have like alerts. So we had our dashboards configured for 3 important things. The first one was business metrics. The second one was kind of like mungled together, which is like your application metrics and your system metrics. Now, business metrics, this was a huge win for us to like win our product owner's confidence because he could basically see anything that he's adding, how quick it reaches to production, and how does it affect the user interaction with the system. So we were showing him after a certain feature was added, how did the downloads increase or decrease, or like how many users stayed on these pages and things like that. Those are the kind of metrics that they like to see. And those are the kind of metrics which you should track as well as a developer on your team to understand like how the software that you put out there is interacting with the users. And we use like a ton of these tools, like whichever one that suited our needs. And we worked on our dashboards continuously as well as we went by because we were like, oh, like when we thought that this one thing was really important, now like we actually fixed that problem, like we automated that problem. It shouldn't happen anymore. So we can just push it down the stack and let's look for some other alert that we should look for. So we worked on this continuously. It wasn't just one thing that was just there. So an example of this is, how many of you have used Hystrix? Netflix Hystrix. So it's a great library. So it ensures that it has circuit breakers. So if any of your dependent services aren't working, we decided that we will show the content to the user anyway because the user shouldn't be penalized for basically like our problem of not being able to put software out there properly. So that was an example of a very good callback we had in our system. So we would see, we were tracking callbacks in our application. Like Hystrix also gives out metrics for you. So we were tracking callbacks in our application, and we saw that like certain services were like, you see here, there is like a huge, what do you call it, like alert there, which means that like something went wrong there at that point. Like maybe a region went down, something happened, but the user got the content anyway. And other things that we were tracking were things like availability zones, and like, is there any CloudWatch alarm? Not like specific alarms. It's like if there's any CloudWatch alarm that's on, then it would just, where's my thing? Yeah. So that one would go red, and like a support engineer would go ahead and look at it. So that was an example of an application metrics. This is an example of a business metric. So we track the user interaction and how much time the user spent in our application. So we send an event out when the user enters the system, and we also sent an event out when the user exits the system. And we were able to see something happening here, and that's around the time when the callbacks were failing, and we were like, okay, there's definitely something wrong. So those are the ways that we were able to like show to the product owner, like this application that you put out there, this work that we are doing in terms of infrastructure, it's for you as well. Like you can add these dashboards. And he was really happy. Going on to the next lesson, an important thing for us was to make sure that we do testing. Now, this shouldn't be a point of contention in this century. Like, I mean, it's important that we have to do testing, and it's important that we have to do testing at different levels. So in our case, so when you talk about microservices, people always say that like, oh, like you have done your development properly, just release it into production, and you can see something goes wrong, just like pull it back or like roll back or like release effects. Now, I was working in a system where like our product owners were like not used to change at a rapid pace. And this was basically like scaring them that they could potentially release software and lose customers. And they weren't basically ready for it. So in our case, we decided, okay, fine. In that case, what we will do is like have a QA environment which mirrors exactly what the production does. And we will run a soak test so that like we have always like a user interaction happening with the QA environment. So anytime we were finished with like a story, we will check whether the QA environment is free, and we would just release it in QA. And because the soak test was running continuously, it was giving us feedback if anything were to go wrong. So that covered like 80% of our cases when things could go wrong. And the product owner seemed to come around after it, like, you know, when he saw that, like, oh, things went wrong in QA, developers are working to fix it. So it was very easy for us to, like, say, once something is, like, QA testing done, it's ready for production. Like, we can release it immediately in a matter of minutes. So once QA testing is done, we would talk about it in the stand-up. We'll be like, okay, we saw this problems, we fixed it. Can we release in prod? It went from a point where, like, the product owner was like, yeah, sure, like, go ahead, release it, it's fine. Like, I mean, if it's done in QA, if all the tests has passed, just go ahead and release it. Like, so it went there, like, in a matter of months. And it was a great feeling for us to be able to do that. So this is like so this was basically like how we thought we did our testing. Like, when we release something in production, it's like Schrodinger's cat. They say that you never know whether the cat is like dead or alive when it's in a box. Like, the moment you open it is when you see it's dead or alive. But no, you can actually test it. If you shake the box and the cat shouts, then it's probably alive. Like, so that's how we tested in our QA environment. Apart from this, like, to enable that our production is always online, we had a ton of other measures that we added apart from just testing. So Chaos Monkey is an important thing that I think if you're working in a microservice environment, even if Chaos Monkey isn't automated into your test suite, just try doing it as like an exercise for a week and see what happens. Like, bring down, like Chaos Monkey will take care of bringing down systems, and you can actually track whether your infrastructure is resilient enough to handle chaos. I think like one of the important things that we did, which was like a no-brainer, and it was really quick fix for all our services, was to add health checks. But the health check would not only, like say for example, the web app, the health check would not only check whether the web app is up and running, the web app is able to like accept requests. It would also check whether it can talk to the authentication service that it was dependent on, or other 5 other services that it was dependent on. So we tied the health checks of a service to be also tied to the health checks of its dependent services. So that was a very, very easy win for us when we broke any contracts between those 2 services. So we deploy something in production, or like we deploy something in QA, or someone deployed a dependent service in QA, then we know that the health checks of the dependent services go down, and we're like, wait, there's something wrong here. Maybe this shouldn't go to production. Maybe we should just stop and see what happens. So just by doing that, it gave us like tons of resources on how we are doing things wrong, and all we had to do was just quick go fix one by one, and it was a very, very simple thing to do. If you can do one thing to your system right now which you haven't already done, please go and add health checks, and also health checks to make sure that it's dependent on like your dependent services. So in terms of testing, we had our so a test pyramid looks like this. You need to have like tons of not tons. You need to have a lot of unit tests underneath, and then on top of it you have integration tests, and then functional tests, and then you can't see clearly. I'm really sorry. That's a contract test there. So you basically want to have something like that. Sorry, that's a journey test. But in our case, it actually became like this. So we had a unit test, integration test, a functional test. And then in between, we had something called as a service test, which was checking whether the service is on by itself is working by sending like dummy requests into it and checking whether we are getting a proper response back. So that was a service test, which was run anytime a service was deployed. And on top of that was the contract test, which is something that our dependent services would give us, so that we add it in our pipeline. And we go like, okay, fine, now this thing has been deployed, the service is working, but is it still working as how my consumers expected it to be working? So that's why we want to test the contract test. And on top of that was the journey test, which was actually replicating how a user interacts with the system. So if we were to just depend on the journey test and not do any of these things, we wouldn't know when something fails, what's failing, basically. So it's important for you to realize, like, how do you ensure that your service by itself is working, and then service with its ecosystem is working, and then services for your user is working. So that's very important for you to think about in your testing strategy. Note that tests are there to validate constraints. They shouldn't be constraints themselves. So if you see yourself, like, whenever you have to add a feature, going and editing like all the way down like the pyramid, then you're probably not testing it at the right level. And that's an indication that you have to have a look at and definitely fix it whenever you can. Lesson number 9 is definitely invest in I should say 10, but it is, sorry, 9. Lesson number 9 is to invest in infrastructure. So this, again, like just so you guys know, this is an indicative chart of how how the story split was. There was actual data behind it, but for reasons I can't share that with you. So this is like an indicative chart. So when we started our application, between infrastructure and feature, at the start we had like 100% infrastructure stories, and then it started like going down. This is for one service. Then we added one more service. This is how it looked. Like, we started getting feature stories at the beginning because some infrastructure work has already been done. And then for the third service, this is how it looked. So as we went by, we saw that the amount of infrastructure code that needs to be done was reducing. So it's important that, like, it can be very daunting when you start with infrastructure. It's like, oh, I have to like reinvent the wheel again. Like, why do I have to do it? But perseverance is key. Definitely, you need to invest in infrastructure. Why wouldn't you at this age? So that's important thing. Like, you need to embrace new technology. It's an evolving ecosystem out there, and you are losing out if you're not actually tapping onto that potential. Digital disruption has already happened. Like, the Blockbuster used to be a big thing. Now, I don't own a TV. I don't own a DVD. My MacBook doesn't have like a DVD slot. Like, I mean, that's where it is at. So people, like, now a lot of things are done towards like your middleman. And if you're not like embracing new technology. And if you're not adopting like things that's already out there, you're going to be phased out sooner than later. And I think it's important for like really old companies to understand this and not fight this just because you have the user base, because it's not going to work out that way. At least maybe for now it works out, but it won't be like that for too long. Banking, every environment like banking, technology, other services, everyone like, is working on this space, and you need to tap into that potential to make things happen for you. There are new kids on the block. I would definitely have you please like go ahead and read about it. If you're high up in the ladder, please ensure that you know like what these things are. The three factors that people say that like it contributes to your personal growth is autonomy, mastery, and purpose. I think your microservices also need to have these three things in them for them to work properly, which is like ensure that it has proper autonomy and it knows what it is doing, it has the right tools to do, and it has a purpose to exist. If it doesn't exist, just don't leave it out there. Microservices helps you to improve in iterations, which is very, very important in agile software development, is to improve in iterations, adapt to feedback. And having autonomy and taking control of like business as well as technology in smaller teams helps you to like deliver software quickly. You have to ensure that there is like high cohesion between your services, but they are coupled loosely enough such that you can alter its state whenever as you need. And you need to be able to like embrace Conway's law. And if your team isn't structured to do that, then that's definitely going to get into the way of like you adapting microservices properly. And why do microservices? It's a lot of fun doing it out there. And as a developer, it gives me like great purpose when I work on something and I don't have to wait for it like 6 months to be released to the user. I think I enjoy it when I see something that I worked on, and I can actually show to my mom, that thing, I worked on it. So that's, I think I deserve bragging rights on the things that I work on. So that's my summary. These are resources. I'm just reading my slides at this point. Image credits, and thank you.